an example of doing global variable register allocation, and this is based on a paper by researchers from Hewlett Packard. Okay, so the first step is to analyze each function to see which global variables are read and written there and how many times. Then the so-called webs are constructed. These are, at first approximation, the set of functions in which a global variable is accessed. But actually, the web is slightly larger than that. And also, there can be different webs for the same global variable. How to construct the webs, we don't go into details here, but we will explain the key idea. Okay, so in the web, in this figure, we can assume that x is used in all functions except b, f, and h. So then what should the web be? First of all, what's the purpose of this web? The purpose of the web is to find a subset of the functions in which a variable is allocated a register. So what is interesting here is that we can come to this subset starting with A, and then if we call C, obviously C expects x to be in a certain variable. The same if it comes to D. But if the program enters this part of the call graph with B, then B might call D. Okay, D expects the variable to be in a particular register. Therefore, B has to load it into that register. So B will be part of this web, even though it's not used by, even if this variable is not used in B. Okay, and furthermore, we say that we see that F is not accessing the variable, but G is. Okay, so we have to keep the variable in this function f, since it's it could be saved and then reloaded when we call G, but that's a too detailed decision to make as the general approach. So we simply say that f is in the same web, but h is not, since it's there's no point in requiring that h allocates a register to x, since, well, it's not needed. Okay, so that's the basic approach. And for each variable, one such web is created, or at least one. And what I want to say is that each variable has its own webs, which is quite obvious. And if the webs intersect, if the intersection is non-empty, then these webs interfere. Okay, so what is also done is to estimate how useful it will be to allocate a register to a certain web. And in particular, we use callee save registers, not caller save. And if the web is allocated a register, it will be given this register in the whole web. And what is done is that some global variables are, so to speak, pre-colored before the normal intra-procedural register allocation is done. Okay, and that means that this estimation must be very careful so that the program does not pre-color too many global variables, which would result in having too few registers available for local variables. Okay, so why is it a good idea to use co-lease registers? Well, function h does not have to know about this variable that used a register in the rest of this part of the call graph. Since if h modifies the register that x is allocated, then it has to restore it afterwards. So x may be allocated to the register in G. H does not use that variable, but it modifies the register. So it first has to store that register as part of the beginning of the so-called function prologue. Okay, so and then before returning, h has to restore that value. And then it means that G can continue using X in that register. Okay, very nice. So, when do we have to load and save, load and store the global variable? Well, it's in the entry points. That means H and B. So in H and B, the variable is loaded into this register, which is used in all the functions here. I mean in the web. And if the variable could have been modified, not necessarily was modified, but could have been modified, then these entry points have to write back the register to the global variable before return. So it's the entry point functions which are, or entry functions which are responsible for loading and storing the value.